So welcome to the EG1003 lecture. Today is just a discussion about EG1003, how it relates to the profession, and all of the different disciplines that you'll be seeing over lecture over the rest of the semester. So we talked about in recitation, this course is designed so that it gives you an intro to all the disciplines in engineering. We want you over this first year to figure out and make sure that you're in the right discipline. When I graduated from high school, went into undergrad, I really had no idea what civil engineering was, what all the other engineering disciplines were. And it took a while for me to really realize what I wanted to be doing in my career. So please take this first year as a chance for you to do what you want. So I'm also a recitation professor for this class. My name is Jack Bringardner. My background's in civil engineering, like I just mentioned. I went to Ohio State for my undergraduate degree and the University of Texas at Austin for my graduate degree, which is where the Alamo Draft House originally started, was in Austin, Texas. So the other things we'll be covering in this course. We want you to develop your professional tool set, vocabulary set, as well as skill set for everything that you'll need to do, especially if you go out for an internship this summer. We want you to be competent in design, and we do this through an interactive format in a lot of the labs where there's a competition, and you can come in first or second place and get some extra credit towards either your lab report or the presentation, depending on which lab it is. There's a big emphasis of teamwork in this class, so we want you to be working together with other people that are in your sections, tackling the problems, coming up with novel designs, using everybody's ideas to kind of brainstorm the best possible solutions, both in your projects and in the labs. And then we want you to communicate those. So you're going to be communicating it to your recitation professor and your recitation TA. Treat your recitation TA like your supervisor. Treat your recitation professor like your CEO or your boss. They are there to give you critique and insight into how to present a little bit better, how to frame things in a little different way and use terminology correctly. So treat this like if you're working for a company and you're being contracted out for a project. They are the people who are reviewing your presentation before you go to the actual customer or client to get you prepared and make sure that your presentation is professional and up to the grade, up to the standard that that company wants. So we do have some business aspects as well as a big consideration for project management and time management. So project management for the semester-long design project that you'll be doing. We'll talk about what the different options are. But also time management, you'll realize very quickly that there are a lot of assignments in this course and they go by very rapidly. You're learning new topics each week. You're going to be doing presentations and lab reports on those topics. So you're learning a lot of new things. What we want you to get prepared for is what you're going to see in the second year. You can talk to any of the TAs in this course. When that really accelerates and the work comes even faster, we want to get you that leg up from what you experienced in high school to what's coming up in the next couple of years. So this is a very large course. In general, most semesters we have 21 sections. Each of you is in one of the recitation sections, and it's taught by a large team of people. So we have TAs, so from the second, third, and fourth year, they've all successfully completed the course. We have recitation professors who are the technical faculty that are in your recitation sections, writing consultants who are adjunct professors here to help you with your writing, and then guest lecturers, some from industry and some from the different departments here at Tandon. So unlike your other courses, your TAs are your major point of contact. Your recitation TA should be the friendly face. Obviously, we want you to feel like the recitation professor is approachable, but we understand sometimes they might feel a little bit intimidated to go up and ask them questions. So the TAs are here as a buffer for you to have a more casual relationship with, to get to know them, understand what their experience is, and help you through this course. But that doesn't just exist for this course for EG1003. We also want you to talk to them about the rest of your time here at Tandon. They've had internships at companies you might want to work for. They might be the president for a professional society here that you might want to join. So go to the Club Fest, go to the career fairs, talk to the TAs about what to do at those things, because they've just done it and they're doing it themselves every semester. Obviously, your reports, your presentations will be graded. This is your main form of assessment. We want to give you feedback throughout the entire semester so that you can make improvements both in your public speaking and your written communication. While there is a focus primarily on communication, if you look at the grade breakdown, it is 70% of your grade. Ultimately, embedded within that is the technical knowledge that you need to do engineering design. So we're putting that forward because that is really important. When you go out into the real world, writing and being able to speak to others is going to be one of the #1 things that you need in order to be successful. But obviously, the technical skills are essential as well. So throughout the semester, we'll be talking to you about your progress. Your grades are there for you to reflect. You'll get feedback on all of the assignments that you submit. Please make sure you're paying attention to all of that and addressing where you can make improvements. Just some information about where we are located. So each one of you is in one of these lab rooms. So 574, 576, and 577. The model shop is a large room that you'll be visiting next week in Recitation. It's the Jacobs Academic Building, 573. This is where all of our projects are housed, and it's where you're going to be completing your projects throughout the rest of the semester. So you'll go there, you'll get to see the projects in person, and make your decisions about which teams you're going to be in. Each recitation is a little bit different in how teams are formed. Make sure you talk to your recitation professor about how that's going to happen next week. You've definitely seen the URLs at this point for both the lab manual and the website. Make sure that you have those saved, favorited, at least for this semester. And then open lab times will be posted soon. And I just want to have one follow-up comment about the academic misconduct discussion that happened in recitation. Plagiarism is taken very seriously, not only in this course, but in the rest of the classes that you take here at Tandon. So please, make sure that this doesn't happen to you this semester. We do report everything that we see to academic affairs, which goes on your permanent record. So don't let this happen. It's a Tandon policy. We wish we could give you a little bit more of a break, but the easiest thing to do is just wait a little bit longer if you don't have enough time to finish your report. We have a fairly lenient late policy. Don't abuse it because it will negatively impact your final grade. But we would rather see something submitted a little bit late or not completed as a report rather than you cheating or plagiarizing any of the content. We have a prototyping lab that'll help you throughout the semester on your project. This is in between labs room 1 and 2, so if you're in either of those rooms for your lab sessions, it's that back room that looks like this. It's JAB 575. Every one of you will be 3D printing something this semester. That includes team logos, so if you want to just do the basic requirement, as well as parts for your robot if you want to modify the obstacle course that your robot is completing, or prototyping components for any of the RAD projects, the VEX Robotics, or the housing project. You'll be able to print a floor plan. We also have help for soldering and Arduino. In addition to that, there will be workshops that we run in conjunction with the Makerspace. So the Makerspace has a number of workshops. If you haven't yet had a tour, you're going to be doing that prior to Lab 4 as a pre-lab assignment. In addition to their workshops, our EGTAs have been working with them to develop a series that is specifically helpful for you in the projects in this course. So be on the lookout for these. These will be posted as an announcement on the website. It's first come, first serve, so when you see the Eventbrite, if you're interested in learning one of these things, click on the Eventbrite details and register as soon as you can. And feel free to stop me at any point if there's a question about something that I'm discussing today. Again, you've heard about all of the meeting times. This is the lecture. Labs are throughout the week for all of you. Recitations are throughout the week for all of you. And then the workshops and the projects are in addition to those standard meeting times. So we will have people coming, talking about their professional careers, their backgrounds, and their own disciplines, talking about some of the sub-disciplines of their area or their specialization. And they'll also talk about how to go about finding careers in those particular paths. There will be some faculty, it will be some guest speakers from outside, but all of them are experts in their field. So take advantage of their knowledge, come prepared to ask questions so you can learn a little bit more, and see what opportunities there are if you were to go to switch into that field, or if you're already in that field, what you might want to do. So the planned lectures, subject to some change, but most likely this is what it will be. Today is just another recap of Intro to EG1003, and we'll be going over the projects you have the opportunity to work on. Next week is going to be a lecture on teamwork and teamwork fundamentals. We will also have some TAs come in and act out how teamwork can go wrong this semester for our project, and a few strategies for overcoming some of those problems. The third week, we'll have a professor who is actually a retired professor, used to be the dean here at the Tandon School of Engineering, previously Poly. He also worked at Grumman for 20 years in industry, which is a major aerospace company. So he has a lot of great experience, and he's going to talk to you about project management and some tools you can use for your SLDPs this semester. Then we'll have people from the civil engineering department and computer science department come in, and in the sixth week, I'll be going over a presentation on some things to consider in the future technologies and the future of work related to AI, data analytics, and how automation are changing all of the fields that you're going into right now. Then we'll have electrical, chemical, and mechanical present, and an industry professional who was one of the lead project engineers on rebuilding the World Trade Center site after the attacks on 9/11. And he'll go into details about all of the different aspects of the multidisciplinary engineering projects that it took to complete that. In the fourth week, on February 18th, from 12:30 to 2, this is during your exam hour, and we have confirmed that no one has an exam during this specific time slot. There's going to be an extra credit lecture in here, so mark this down on your calendars now. I highly recommend that you come. In the past, we've been a little bit discreet about how we do this, but the extra credit is going to work this way. The Lab 1 reports that you're submitting next week are going to be graded very harshly. Our goal is not to just hurt your grade, it's to give you as much possible feedback as we can. If you come to this extra credit lecture where one of our writing consultants, Professor Osborne, will be talking about the ins and outs of writing lab reports, you will be able to rewrite that Lab 1 report. So mark it down on your calendars now. You will have a chance to earn back all of the credit that you missed. But do your best job with the Lab 1 report. You can get a real good sense in the first week of how well you're doing in terms of the writing expectations in this course. So the general rules for lecture, again, make sure you close your laptops, no cell phones, so put your cell phones away. No talking. Make sure everybody's staying quiet again. Do not have constant murmur or whispering, even if it's just the people next to you. And then the slides will be available after most lectures. The World Trade Center lecture has some proprietary content that we're not allowed to make available to you. But that's one of the last lectures, just to give you a heads up. So the labs, the real goal of the labs is to develop your skills through a number of different software platforms, programming languages, or other concepts that you have to apply in a hands-on setting. There are 4 design competitions, and those design competitions should be kind of fun. They allow you to get some extra credit, but you're also competing to see who can come up with the best design to achieve the goal of that particular lab. They're designed to cover many disciplines, so chemical engineers, computer scientists. Each lab should cover at least hit on each of the disciplines here at Tandon. A few we've designed so that they are multidisciplinary and integrate areas from multiple majors. So these labs, in Lab 1, what the main goals of these labs I want to go over really quickly. When you're doing, if you haven't done it yet, if your lab is tomorrow, the virtual product dissection, or if you've already done it and you're going to be writing your lab report on it and reflecting about what you did, our goal was for you to think about how things work. Everything that you see around you is something that has been designed by an engineer and been manufactured by people that have received the specifications from that engineer. So when you're talking about brainstorming designs for your water toy, try to be as explicit in your language about what the actual design will be, what your product is that you're actually generating. And then tell us, using visualizations from the software that you used in SolidWorks, What parts are you bringing in from the variety of different products you could have dissected to add to your design of a water toy? Now, obviously, it's more of a thought experiment. You're not designing the actual or building the actual water toy, but we wanted to give you some concrete goal to think about. You need to develop a toy for a small child that's going to be safe, but also fun. And to start thinking about how to brainstorm and bring these ideas together, because it's something you're going to be needing to do at every stage along the project this semester. Next week, you're going to be doing boom construction. You're going to try and create a structure that can hold the most weight as possible. This is one of the first competitions. It's a lot of fun. Go in there in the labs. Just be safe. Be careful with all of the wood dowels, as well as whenever anyone is cutting a wood dowel, make sure you're being careful. In the third lab, you're going to be learning how to use sensors and automate a robot. This is going to be done with the Lego EV3 kits that we have. The fourth lab, you're going to be redesigning a part to make it as strong as possible in computer-aided design software. So you're going to see what the precursor to finite element analysis can do by designing parts and minimizing stress. In the fifth week, you're going to be using Arduino boards to design a temperature sensor, as well as designing a thermal insulator that will keep the temperature of an object as warm as possible for the longest term. So in a lot of these cases, you've got to be considering what are the constraints that I have, what are the design materials that I have, and design options that I have, and what decisions I'm going to make throughout the lab in order to accomplish what the ultimate goal is. Then we're going to introduce you to some software called LabVIEW, used by a lot of mechanical engineers and electrical engineers for automatic controls in large manufacturing settings. Digital Logic will introduce you to how computer chips actually work. So you'll be working with some integrated circuits in order to design a system which resembles a real-world security system, although it's a bit of a fun activity that's not so real-world. Then you'll be building a sustainable energy vehicle powered either by solar or wind power, and finishing off with biomedical forensics and a small little murder mystery that takes place within the TA environment for EG. So you can see the competition labs that are here, but the goal for each of these labs is to have some fun, work on these projects as a team, and then come up with the best possible design that you can. In recitations, you'll be presenting on those labs, or some of the weeks you'll be talking about what you've accomplished so far with the project. The goal for these is to help you with your public speaking skills. We want you to be able to effectively communicate whatever your ideas are. If it's an entrepreneurial startup that you want to complete, if it's a software, or if it's some software development that you need to explain to a boss, and we will be giving you some feedback about how to improve that week after week. So I'll go over in more depth the semester-long design project in just a minute, but the main goal is for you to have some experience with project management. This includes using software to be able to track your schedules throughout the entire semester, as well as testing, redesigning, and iterating through the design process. And then at the end of the semester, ultimately having deliverables turned in on a deadline. So these are some of the projects just listed here. We have autonomous robotics projects. I'll talk about more in just a minute. So we have courses like this that the autonomous robot will have to work on. So you program it from scratch. You press a button. You don't have any remote control over the robot, and it must complete the tasks. This is a past design for a building that a group of students came up with. So the goal is you're going to be designing a building on the Brooklyn campus that'll have some dorm space, as well as some recreational space and classroom space. And we want you to be as innovative as possible with a focus on sustainability and environmental design. And then Tatiana will talk here at the end of lecture about your opportunity to participate in the RAD project this semester. So if you find a team that is interested on designing basically your own problem, and then throughout the entire semester building a prototype that can solve that problem, then make sure you're paying attention for Tatiana's presentation in just a minute. 3 examples of winners from past semesters. If you do choose to do the RAD project, at the end of the semester, you're going to be able to come up here in Pfizer Auditorium and present on stage. Give us your Shark Tank-like business pitch to explain why we should invest in your product. And if you win, you will win a small monetary award and the recognition from EG1003, as well as the deans for the effort that you put into the project. Part of that will be inviting you to come back next year in convocation. If you remember in convocation, back to August, you can think back that far. I know it's been a long fall semester. These projects were there, featured as some of the top production from EG1003. So prosthetic feet, this pet toy that was just a holographic design, and then some blind assistive technology, just some samples of what kind of things that you could be doing in this course. So now I want to introduce you a little bit more to engineering. Some of you in recitations might have had some discussion about this, but we want to frame it around what we're thinking about, what we want to convey in this course in this semester. So engineering really is about ingenuity. It's about designing based on certain standards, making sure that you're paying attention to the technical specifications, the cost or the budget that you're limited by, as well as the schedule and the time that you have to turn these projects around. But ultimately, engineers do make the world go. We are the ones that solve problems. We are the ones that, when the stern business student has this really great idea about what we're going to design, I apologize if anyone here is from Stern, we're the ones that actually execute that design. We're the ones that develop the app that they have this great idea about. We're also the ones that are able to come up with these innovative ideas because we have a better understanding of how they actually work. But engineering is also about altruism and helping other people. Most of the things that you design and create will be things that help the rest of the people in society. So we design things that have new capabilities, things that are more efficient or save money. And then we have the reward of being the ones that actually implemented that design and made it possible. And in most cases, like we'll talk about significantly next week, this is done through teamwork and working together with other people. It's very rare nowadays with the scale of engineering projects and the broad spectrum of design problems that people are solving that you cannot do most of these projects or solve most of these problems as an individual anymore. You have to be able to learn to work on a team to be able to accomplish these tasks. And then you all get to share in the credit and kind of be rewarded as a team for your effort. So we also, there's a heavy emphasis on analyzing all of the designs that have been made in the past and how they're working, coming up with new designs. In a lot of cases, yes, we do have procedures and code books and policy manuals, but a lot of the times you've got to use engineering to figure out how to write that code or how to actually implement that machine learning algorithm or how to design something so that it doesn't fail. Because it might not have been done before, or there's some new feature that they're trying to add to it that you need to be able to think through all the potential pitfalls for. So then you need to be able to communicate these ideas, both to other people that are maybe your colleagues at work, but also the general public. So you might be talking to somebody with an engineering background who has the technical skills and knows the terminology that you're using, but you also need to be able to talk to people that really want the big picture overview or the headline rather than the entire details of the story. And it's your responsibility as an engineer trying to communicate this idea to be able to understand who your audience is and gauge at what level should you be speaking to them. Do they want all of the technical details? Should you start talking about the code and how you organize the algorithm? Or should you start with just the fundamentals of this is what this software does? So pay attention to your audience. And then ultimately, again, teamwork is necessary to make these things happen. And everything that you do in the future is going to be dependent on whether or not the product or the operation that you're conducting is profitable. So from a business perspective, it needs to be able to make money. You need to know what are the costs that go into the development of this, and then what is the eventual revenue and return that you're going to get on those costs. So why this course? Obviously, it's a required course. That's why you're in here. But it's a required course because these are essential skills that you are going to need to be successful. So please work on coming at it from that perspective. At this point, you might know what engineering is. You might have somebody in your family who is an engineer, or you might have had an engineering course in high school. But I'd like to challenge you to think, do you really know what engineering is? And again, hearing from different experts in this course, at the school, can give you a better sense of what engineers really do. A lot of the courses that you're taking right now might seem very similar to the courses that you took in your senior year of high school. Physics, calculus, chemistry, biology. What we want to do is give you a chance to apply those skills immediately, because it takes a while until probably your second or even closer to your third year where you really get to start using applied engineering concepts. So we want you to have that experience in the first year to get you excited about what engineers can really do. And we want you to develop these badly needed skills in industry. So when we talk to programs or companies that are out there, they say what they've identified that prepares students the best for real-world work are these types of team-based projects where we simulate what they're going to experience, where you're going to experience when you go out and you work for a company. Projects where you design, analyze, test, and build, as well as real-world problems. So I challenge you to practice these things with the mindset that it's going to help you in the future. So, the skills, again, that we hope that you learn: the ability to design, the ability to manipulate different tools and different data that you're going to be using as an engineer to understand how that data really works, and then also to present on those topics. So we bring in things that are commonly used in industry, like LabVIEW, or tools that are being integrated into things like the Internet of Things, using Arduino for connectivity or Raspberry Pis. But those are ultimately just tools. The tools will eventually change, they'll evolve over time, but we want you to practice using these tools now so that you can experience what it's like to actually interact with the real world. It's great to have the theoretical conceptions of what computer science is, how to develop an algorithm, but until you have to figure out how to design a product. Well, last year, I mentioned this in Recitation multiple times, we had a team that put together a rad project that was an automatic pet feeder. So it released pet food as well as water on a regular schedule that could be programmed using an app. They did a really great job. Designing a lot of the mechanisms was difficult. They had to laser cut certain parts. They had to 3D print other parts. They had to code all of it manually. They didn't start with any base code. They had to do everything from scratch to be able to come up with how do you bring a Google Calendar schedule into this app environment? How do you use that to actually control the Arduinos and the motors that are working within the individual device? So those are the types of the things that we want you to be able to practice. Now, we know you don't have significant background with these skills, but we want to give you the support. The TAs are here for that. The makerspace and the prototyping lab are available to you to be able to develop these skills. And it's okay if you struggle this semester. But this is a first chance to take a stab at something that you want to do that's really innovative, because you'll have multiple chances over the rest of your time here at Tandem to be able to do this. So some more skills. If you look at what are the top skills that are trending today, what's going to be expected by around the time that you're going to be graduating, there's a big shift of skill requirements, and I'll go in more depth than this in my 6th lecture, from just being able to do the technical work to a focus on kind of critical thinking, an understanding and a need for lifelong learning, and the ability to work in teams and act as a leader regardless of your role on the team. So practicing these skills that are coming up, the complex problem solving, having the emotional intelligence to understand how people and personalities will interact around you is what's really important. The things that are dying, the ability to memorize, manual dexterity. These things are being replaced by computing and automation in a way that by the time that you graduate, those skills will not be nearly as valuable as these higher level thinking skills. And that's what we want you to use throughout the semester. So, obviously, there's a major emphasis on quality. As engineers, computer scientists, we want to develop and design things. We want to do them right. We want to make sure that the customers are happy. We want to make sure that it is possible to be repeatable, that our computer-aided design drawings have the proper dimensions, the specifications that we print out in addition to those, have all of the detail that a factory could take that information that you communicated and immediately use it and mass produce it. And we want you to think about what are the metrics to confirm that that's happening. And that's why we want you to think about your schedules and your budget throughout the entire semester. And then this final comment about the idea of continual improvement. As an engineer, you can always become better. You can always learn new tools, bring new tools together. You can always learn from other people. Regardless of their level of experience, other people will have ideas that will make you a better person and a better engineer. So in this class, though, to be successful, we've got a number of resources on the lab manual. You've got sample labs and sample presentations that you can take a look at to prepare for this first round of assignments that are due next week. And then we will be giving you feedback. You'll be getting grades as well as an overall assessment at the end of the semester to give you a sense of where you are. But the grading throughout the entire semester is with the goal of helping you to improve and get you to the point that you want to be at the end of the semester. And then ultimately, we want you to have fun. That's really what this course is about. The labs should be pretty fun, pretty exciting if you take them seriously and put some effort into it. The projects can really be whatever you want it to be, depending on if you choose one of the pre-selected options, or you get to work on whatever prototype you want to do. And don't forget to take advantage of the TAs. The TAs that are here in lecture, the TAs in lab. When you go into open lab throughout the week, it's open for dozens of hours each week. There are different open lab TAs that are staffed in there. Don't hesitate to go up and ask them questions about the course or questions about anything else related to your degree here, your first year here, your goals, and what you want to be doing. So let's talk about some of the more fun things that you're going to be doing this semester. The semester-long design projects. So next week in recitation, make sure that you are there. If you are going to miss, make sure that your recitation TA and professor know, because otherwise you're not going to have any say and you're going to be stuck on a project and with a team that you have no input on. So today is an overview of the different projects that you could be choosing from. You'll have a better sense of this in recitation when you go to the model shop and you can actually see them in person. But there is additional information about each one of these on the lab manual. So if you have specifics that you would like to know regarding the benchmarks, the milestones for each of these individual projects, all of that content is available on the lab manual. But feel free to stop me if you have a particular question right now as we go over it. So these projects will be for the entire semester. The teams will form next week, and then the project continues until the final week when all of the submission and final deadlines are. Your teams are typically going to be groups of 3. In some cases, there might be groups of 4, particularly if you're a RAD project or depending on the number of students that are in your section. The 4 major projects are an autonomous robot that works over an obstacle course, the housing and innovation in Revit. Revit is Autodesk software where you can do every aspect of building design using pre-existing libraries. You can pull in furniture, you can pull in windows, and design a fully rendered building. So if you've ever had the interest of designing your own house or your own apartment, or designing any kind of structure or building, it's a really great opportunity. And then the last one, the Rapid Assembly and Design Challenge, I'll give you a couple slides about it, but then Tatiana will talk to you in more depth of what you can do this semester. The biomedical device project is one that is actually very closely associated with the Rapid Assembly and Design Challenge. It used to be that a lot of students were asking to do either a prosthetic or some sort of wearable technology. We found that those RAD projects were very often successful. So what we did is we took the standard materials that we give for each of the RAD teams, created a specialized kit that included the biomedical parts that most people use, and then created a separate kit. So it's a little bit more guided. You know what you're doing. It's going to be a biomedical part, but it's still open-ended in that using the sensors that we give you, you can come up with your own original design. So remember that the semester-long design project is 30% of your grade. Half of that grade comes from the completion of the project. The other half of that grade comes from a final presentation where you are delivering all of the content that you worked on over the semester to your recitation professor and TA. Throughout the semester, we want to make sure you're staying on top of the project. We don't want you to get to the 10th week and realize that you haven't done anything on the project. So there are 2 benchmarks that you must complete. Benchmark A is in week 6. Rather than having a traditional lab, in the 6th week, you're going to be doing what's called the first model shop session. So in that lab period, you're going to be going into the model shop, you're going to be working on the project, and at the end of that period, benchmark A is due. Now the worst thing you can do in this class is wait to start your project until that benchmark A model shop session. So my advice to you is have benchmark A completed prior to that model shop session and use those 3 hours as a dedicated time to get as far through the project as you can. So the 2 benchmarks, week 6, week 9, are pretty much set up so that the project is broken up into essentially thirds and keeps you on track throughout the entire semester. There are penalties for late completion, as well as rewards if you complete these early. So 1 week early completion of your benchmark is extra credit. If you're late at all, it's 30% penalty on the benchmark grade for 1 week late, and then 70% penalty for 2 weeks late. At the end of the semester, which would be basically considered benchmark C, but we call it commissioning because this is the end of your project. This is where all of your tasks that are required for your project must be completed, and this must be done prior to actual submission of all of the deliverables for the project. So you'll be working on CAD designs, your project schedule, your code, everything that you do for the project will be submitted at the end after you've completed it through the SLDP submission portal on the EG website. All right, the housing and innovation in Revit. So if you're not aware, there's a new building being constructed in Manhattan, 181 Mercer Street. It's designed to be multi-use for NYU students. This includes multiple gyms, swimming pools, tennis courts inside the building, as well as housing for faculty and students, commons areas, teaching facilities, classrooms, other facilities, offices. The goal for this project is we have a lot of land that we're not quite sure what we want to do with here at NYU. So we're going to give you the chance to design your own equivalent multi-land use building here in Brooklyn, as extravagant and as innovative as you want, with an emphasis on LEED accreditation. So Leadership in Energy and Environmental Design is an accreditation agency that you've probably seen around New York City. A number of buildings are LEED, gold, or platinum accredited. What they do is they go through and they look at the buildings to see how environmentally friendly are they. Do they take into consideration different aspects of lighting, energy usage, water usage, transportation in and out of the building? All of these things go into the general assessment of the sustainability of the project. So we want you to focus on that and learn how to go about designing and creating your own building. So the first benchmark, you'll have to create a recreational space, whatever you choose that to be, as well as 20 and 40-person classrooms. Benchmark B will be all of the classrooms, an additional facility, and then the electrical and plumbing plans for the dorm room and commissioning will be your floor plans for all of the floors as well as your lead implementation plan. So we will require that you design a LEED Gold building. So you'll have to accomplish 4 of the 6 main areas for LEED certification. Extra credit is if you go for the last 2 and you get LEED Platinum, as well as additional prints in addition to your mandatory print for your building. Any questions on the housing and innovation in Revit? This is all done in computer-aided design software. You will have the opportunity to 3D print a physical model to be able to represent what it will look like. But the more innovative you are with this project or with any of the other projects, the more reward you'll get at the end of the semester. Not only for accomplishing it, but also the professor might award you with an innovation award. All right. Particularly innovative projects will also be nominated for the Nick Russo Award. Nick Russo was a previous general engineering faculty member who passed away a few years ago. But in his honor, we give an award every year for each individual project. The top project with the most innovation, most effort put in by the team will win the Nick Russo Award and also be invited to convocation with those winning RAD teams for the following year. All right, so we'll go more into RAD in just a second, but the main goal is all of you have your own ideas about what are the most challenging issues in today's society. What are the things that engineers can really be solving? So we want you to brainstorm whatever it is that you see as a major problem that can be solved with technology. So you identify this, you develop it in the first couple of weeks of the semester, and then the rest of the semester you actually manufacture and build your proof of concept or your initial prototype to show you can solve this problem using technology. You'll be given a kit that has an Arduino, a Raspberry Pi, and access to multiple sensors that we have available, as well as motors and other things. And then you'll be given a small budget in order to make purchases that might be specific to your particular project idea. And then take advantage, ideally, of all of the resources, workshops, the prototyping facilities that we have, and the makerspace. So the initial benchmark will be your initial code, initial physical prototype, and what is called a design feasibility report. So you're going to write a report that tells us what your goal is for the rest of the semester and how you're going to accomplish your objectives. Benchmark B, you're going to have a partially functional prototype, and commissioning will be a full proof of concept. So any additional functionality, we have a few things, including web apps or a website or additional sensors or creating or adding some sort of IoT connectivity, Internet of Things connectivity to your device can be extra credit, as well as 3D printing and other advanced manufacturing. And I mentioned biomedical devices came out as an offshoot of that RAD project option. So this is either a prosthetic limb or a wearable device. We have a predefined kit, so it's a little bit less of a burden on you to select what parts you'll actually need. And you also have the chance to experiment with things like laser cutting or CNC milling for your project. So you will, in the first benchmark, have your initial CAD model as well as some functioning code. Then you'll have, in your benchmark B, use of your machining method and all of your parts manufactured. And part C, you'll have your completed prototype again. So any questions before we get into more detail, where you can ask Tatiana everything you want about the RAD projects? Everyone in here is capable or is able to select RAD as a project. It's up to you if you want to choose one of the predefined projects or this completely open-ended option. In this class, I mentioned that you'll have to do some sort of 3D printing. The standard for that in most of the projects is a color logo for your team. So your team is also going to be a company. This company will come up with your own company name, and the logo is the bare minimum requirement to be 3D printed this semester. You can replace that, though, with some of the more advanced extra credit 3D printing. And then this is listed for each project. So the robot projects, you could do a robot part or a course modification or a 2-color logo. The VEX project is the same as the EG3 projects. However, the Arduino and the Arduino shield that controls the motors is currently just that. You have the opportunity to actually build a case around that entire motor controller brick. The housing innovation in Revit is a little bit different from the others. You will have to create a printed floor plan as a requirement to show and demonstrate your understanding of the computer-aided design, drawing, translation into the real world. And then printing additional floors or other parts of your building can be treated as extra credit. For the Rapid Assembly and Design Challenge, Tatiana will mention in a minute that there's a mentor associated with each of those. They will help you to determine what your mandatory 3D printing is, as well as any additional extra credit printing. And then similarly, you'll be seeing the same thing from the biomedical devices. So the prints must be original. You can't plagiarize from any other sources. The logo cannot just be pure text. You must be have a contingency plan if there is a backlog in the printing. We have set deadlines throughout the semester to make sure that we're keeping you on track, but make sure that you have a backup and you're not dependent on that print being ready because of the potential for a backlog. And then if you get it approved in advance, you can use some advanced manufacturing like 3D or laser cutting in place of the 3D printing requirement if you really choose so. So any other questions before Tatiana takes over and explains more about what RAD is? Okay, yes. Mm-hmm. So it's a mock competition internally for us in EG1003. However, I've actually shared a couple of the building designs with the facilities managers for NYU. The land that we give you is the existing very old building, Jacobs Building, which is just north of Rogers Hall. So there's no immediate plans, and it's unlikely that anything that you design will be integrated, though you might be working for the architect of the future that is designing it. So keep that in mind. All right, so please welcome Tatiana to the stage. Have a great semester. Once Tatiana wraps up, we'll be good to go.
Thank you, Professor Bringardner. Can y'all hear me? I wasn't sure. Are we good? Perfect. All right. So my name is Tatiana. As Professor Bringardner said earlier, I'm a third-year computer science student here. I'm one of the deputies of R&D, the Research and Development Committee, as well as one of the RAD directors alongside Frank, who unfortunately couldn't be here today. I'm just going to talk a bit about the Rapid Assembly and Design Challenge, which is an amazing opportunity that we provide here. So just a quick overview of what we're going to talk about. So what is Rapid Assembly and Design? We call it RAD. We're going to call it RAD for the rest of the presentation. It's kind of a tongue twister. These are innovative interdisciplinary projects. You're not just doing a computer science project. You're not just doing a MECD project. You're working to integrate all of these different fields together into one functioning proof of concept to try and prove what your idea is. We want students to use the iterative design process, so designing, building, testing, iterating, and then innovating in order to create these proof of concepts. All you need in order to complete a RAD project is to have a problem that you want to solve. It can be a problem that goes along with one of the UN Sustainable Development Goals, trying to end hunger, trying to end poverty, trying to promote gender equality, or it can be anything else. But all you need is an idea that you want to implement. So some previous projects that have happened in the past are, for example, all the way on the right here is we've had a lot of prosthetics. We've also had, at the very top left, a personal navigator, so blind assistive technology, as well as SpeakSign, which is an amazing project which uses computer vision to watch someone's hand for sign language. So what you get as a RAD group, you'll get a standard prototyping kit, which includes Arduinos, wires, simple things that almost all RAD groups need in order to complete their projects, as well as a $100 stipend to buy any additional materials that you might need on Amazon. And then most importantly, what you'll get is a RAD mentor. This is a TA who has been extensively trained in RAD and technical skills, who will help guide and support you throughout this project. They're your #1 point of contact for any problems you might have. They'll also be the person that helps you set and meet your benchmark and commissioning tasks, as well as any extra credits you might have. So how it works, just like any other SLDP group, next week you can form a group in your recitation. Week 3 is when the RAD topic application is due. It will be due the midnight before your recitation. This is where you're going to detail out 3 of your ideas for a RAD project. At the end of the week, the professors will go through all these and pick a project for you. And then week 4 is when you have your first meeting with your mentors. At this meeting is where you'll set all your different tasks and kind of plan out how you want to accomplish your goal throughout the semester. So why would you want to do a RAD project? Most importantly, you have way more independence than in other projects. It's your idea, and you get to decide how you want to implement it. All we really care about here is that whatever your goal is, you achieve it. We're here to help you in any way you want to do, but at the end of the day, it's your idea, it's your dream, it's your vision. If you're the type of person that likes that type of freedom, RAD is a really, really great option for you. Another thing that's very important is getting the technical skills, especially for a lot of you, this is your first year, first semester here at NYU. Having these different engineering skills is a great bonus, as well as a great way for you to prepare for working with other majors. I know that it might seem like you're your major and that's all you're going to do here, but I promise you, you will work with people in other majors a lot. And so it's a good way for you to prepare yourself for working with all those different people in different disciplines. Another thing that's really, really great is project experience. I don't know how many of y'all have been to a job interview, but they always ask the dreaded question of what's a project you've worked on you've been proud of. This is a great one. It's a great way, it's a great project for you to talk about. There's a lot of different parts and pieces and skills that you need in order to complete this project. So it looks absolutely beautiful on a resume, and it's a great thing that you can talk about with recruiters. And then lastly, one of the things that's really amazing is that RAD showcase that we have at the end of the semester. You get the opportunity to present here in Pfizer, which is a really great practice for public speaking, as well as you can participate in that Nick Russo competition to maybe win some money, and also be able to present a convocation next year. So I can take any questions now, but I'll also be here after lecture. And if you have any questions that come up later, you can always email us at rad@eg.poly.edu. Feel free to ask us any questions you might have about RAD or any other of the SLDPs. We'll be happy to answer.